this is just going to be a quick video going through some review problems for Mod 2. So you can obviously rewatch the old videos to get more in depth, but this is just kind of a quick overview of what we covered in Mod 2. Okay, so one of the things we covered was just graphing linear equations. So y equals mx plus b is the easiest form to graph. This one's trying to trick you a little bit. Mx and b, we can just switch them. So if I rewrite it as y equals -3/4 x minus 1, then I can see my b is -1, and my slope is -3/4. So I'm going to go down 1, 2, 3, and over 1, 2, 3, 4. And then connect, and we have our line. Remember, all we need to graph is 2 points, okay? And just put arrows on the end to show that that's going to continue forever. Okay, using intercepts is taking turns plugging in 0. So if I plug in 0 for x, the x is going to go away, and I'm going to have 4y equals 8, divide by 4, so I get y equals 2, meaning that is my y-intercept. So on the y-axis, put a point at 2. Now I'm going to switch and put 0 in for y, so 4y is gone, and I have -2x equals 8, so x is -4, meaning that is my x-intercept, and then I have 2 points that I can again connect to create my line. Okay, number 3, this is an inequality. So remember, graphing inequalities is very much like graphing lines, but we have a dashed line or solid, and then I shade above or below. So I'm going to put this in y equals mx plus b form by adding 3 to get y by itself. So we have y is less than -1/2 x plus 4. So y-intercept is 4. Slope is -1/2, so I'm going down 1 and over 2. And I'm going to keep this one going a little bit for you guys just so I get my line. 1, 2. There we go. Okay, this one is a less than, not less than or equal to. So I'm going to make my line dashed. Still putting arrows on the end. Okay. And then this says y is less than, so we are going to shade below. Remember, we don't have to test a point when it's in this form. You always can, though, if you want to. Okay, piecewise function. Remember, these are 2 different graphs, but given a certain interval where they exist. So the first one is just the line y equals 3. So that is a horizontal line through 3, but it's saying it only follows this function when x is less than -1. So -1, I'm drawing a vertical line there, dotted line, is right here. Everything less than -1 is to the left. So I'm going to keep the part that's less than -1 and get rid of everything to the right of -1. And it's less than, so I'm going to put an open circle right on that kind of boundary point. Okay, next I'm going to graph this line, y equals x plus 2. So my y-intercept is 2 and my slope is 1. So up 1, over 1. And I only have to go to the point where x is greater than or equal to 1. So I'm going to go to the point where I hit that boundary of -1, close circle, because it is or equal to here. Okay, and then I'm going to draw everything to the right, but I'm not going to draw this line to the left of -1 because it only follows this line for when x is greater than or equal to 1. And then I'm going to erase my little boundary line here, but it is helpful for finding where our lines need to start and stop. Okay. Here we're asked to write an equation of the line, and we want it to contain these points. So no matter what form I use, I need the slope. So I'm going to use my slope formula first. y2 minus y1 over x2 minus x1. Oh. Okay, so I have -6 minus -3 over -7 minus -4. So those double negatives again turn to addition. So I have -6 plus 3 is -3. -7 plus 4 is -3. And -3 divided by -3 is 1. So I'm going to use point slope form, which is y minus y1 equals the slope times x minus x1. This form is nice when you don't know the y-intercept. So I'm going to use one of these points. I'm just going to use the first one. So y minus the y-coordinate equals the slope times x minus the x-coordinate. And then I'm going to again simplify the double negative and write it as y plus 3 equals 1 times x plus 4. And then if we wanted to change, so this is perfectly sufficient. They didn't specify what form they wanted in, so this is the equation of the line and point slope form. If they asked specifically for slope-intercept, I can distribute this 1, which doesn't change anything, and then subtract 3 to get y by itself. All right. Okay, here we're given the equation y equals negative 4x plus 3. Okay, so it's a line that has a y-intercept of 3 and a slope of negative 4. So perpendicular lines, remember, have opposite reciprocal slopes. So opposite would make it positive, and reciprocal means I'm going to flip the fraction. So it's going to be positive 1/4. Parallel lines have the same slope. So if I want a line parallel to this original one, it also must have a slope of negative 4. This one is asking me to use this equation, write a line perpendicular to this one, so I already know the slope has to be 1/4, but it has to go through this point. So I'm going to use point slope form. So y minus 6, the slope I know has to be 1/4 to make it perpendicular, times x minus negative 1, or x plus 1. All right, we did some basic solving review as well in this module. So this is a proportion when I have a fraction equals a fraction, and I can cross multiply. So 5 times x on one side of the equal sign, and then 2 times x minus 1 on the other. So that is a way to clear the fractions and solve anytime we have a proportion. So I'm going to now distribute the 2 and get x by itself. So first I'm going to get them all on the same side. So I'm going to subtract 2x, not 3x. So I get 3x is equal to negative 2 divided by 3. So x equals negative 2/3 is our solution. All right, okay. So what if we're solving and we get something funky at the end, like no x's left, they cancel out, and I'm left with something like this? This is where I have no solutions. You saw this in one of the videos. I use this notation. That's the empty set. That also represents no solutions. And another phrase we've used is this is called a contradiction, right? 4 does not equal 6. That's a contradiction. If we get something that's true at the end like this, but our x is also canceled, or any variable, this is infinitely many solutions. Okay. Instead of the empty set, we can say all real numbers would work for our variables, or this is also called an identity. So instead of a contradiction, it's an identity. It is always true no matter what we put in for our variable. Okay, last part of this unit was inequalities. So we are going to solve and graph on a number line. So same as solving, we're going to isolate the variable. 2x is less than or equal to 6. Divide by negative 2. Anytime I divide by a negative, we have to flip the inequality symbol. So I have negative 3, close circle, x is greater than or equal to, so it's going to the right. Now it says express our solutions in interval notation. So my leftmost value is negative 3. I'm going to use a bracket because negative 3 is included as a solution. And then going forever to the right means it's going all the way to positive infinity. We never use a bracket on infinity, just parentheses. Okay. All right, absolute value. We have, get that to clear again. There we go. We need to isolate the absolute value part first, and then remember we set up two equations, one to equal the negative value and one to equal the positive. So at first, this 6 is not in the absolute value, so we're going to add it to both sides. So I get absolute value of 2x plus 1 equals 4. So now I set up two equations. I have 2x plus 1 equals negative 4, and 2x plus 1 equals positive 4. Okay, so I subtract 1, 2x equals negative 5, divide by 2, x equals negative 5 halves. Subtract 1 here, 2x equals 3, divide by 2, x equals 3 halves. So my two possible solutions that would make that absolute value equation 2 are negative 5 halves and 3 halves. Okay, now combining the two. inequalities and absolute value. Remember, if it's greater than, it is an or inequality. So I set 1 as it is, or, and then I keep the expression the same. Oh, 6. Flip the sign and grab the negative of that value. So now solve. So subtract 6. So I get x is greater than -3. Or subtract 6 here. X is less than or equal to -9. Okay, so I have -9, -3, close circles for the or equal to parts. Less than -9 is to the left. Greater than -9, greater than -3 is to the right, and or inequalities will always look like that. And then again, we're asked to express it in interval notation. So here I have 2 pieces, right? I have this left piece and the right piece. So we can use the union symbol for that. So left goes from -infinity up to -9. Okay, bracket for including that. Union symbol, because I have a second set of solutions here that I'm going to include, and it goes from -3 included all the way to positive infinity. All right. This one is kind of touching on review of transformations, you guys, from our previous unit. So let's first graph the parent function. So y equals the absolute value of x is just a vertex on 0, 0, and it has a slope of 1 going one direction and a slope of -1 going the opposite direction. Okay, so what these transformations do, right? We're going to kind of go, think order of operations. We're going to work our way inside out. So this one, we're going to move right 1. This is going to reflect and stretch by a factor of 3. And then this is going to move up 4. So I am going to pick 3 specific points to kind of help us with this. So I'm going to do 1, 1, -1, 1, and maybe let's try one more. Let's do 2, 2, and 2, -2. So really I have 5 points there, okay? So we are going to move right 1. Okay, so I'm going to start with just the vertex here. And then I'm going to reflect it over the x-axis and multiply by 3. So 0 multiplied by 3 is still 0. So this one just moves right 1 and then up 4. 1, 2, 3, 4. Okay, so that point is now here. Okay, so now let's do like 1, 1. So 1, 1 moves right 1. It is multiplied by -3, so it's going to come down here to -3, and it's going to go up 4. 1, 2, 3, 4. Okay, and because it has that nice symmetry over this, this is like a axis of symmetry for the absolute value, so this point's just reflected over here. Okay, so let's try 2, 2. So 2, 2 moves right 1. It's multiplied by -3, so it's now down at -6. And then it moves up 4. 1, 2, 3, 4. And then again, that one's reflected across here. Okay, so what it looks like, let's see if we can see all of our transformations here. Okay, so we have right 1, reflected and stretched by 3, so that's why it's looking skinnier, and then up 4. Okay, that is it for the Mod 2 review, guys. Thanks for watching.